For epilepsy, there is hope. Hey podcast listeners, Tori Robinson here for Epilepsy Sparks Insights, a podcast about epilepsy, epilepsy research, common comorbidities and all of the fascinating science behind it. Whether you have epilepsy, are a family member, a neurologist, neuropsychiatrist, therapist, neurophysiologist, scientist or researcher, Epilepsy Sparks Insights is designed to help you learn more about epilepsy from the other side of the table. I'm a person with epilepsy and some missing brain tissue. I hope to help bridge the unnecessary gap between patients, the public, and the aforementioned. Because epilepsy research and science are cool. Last week we had a brill chat with Associate Professor Gabriele Lignani, the Principal Investigator, Senior Research Fellow and Biotechnologist from the University for Neurology and Neurosurgery, Queen Square, London. This week we are talking to Professor Sándor Beniczky, a neurologist, a clinical neurophysiologist and epileptologist. Sándor is also Professor of Clinical Neurophysiology at AARHUS University and Head of the Clinical Neurophysiology Department at the Danish Epilepsy Centre. Sándor is actually also the chair of the Joint EEG Task Force of the IFCN, or the International Federation of Clinical Neurophysiology. We need longer words, right? A member of the European Reference Network for EpiCare, Editor-in-Chief for the publication of Epileptic Disorders, which is an ILAE publication, and a leader member of so many committees in the ILAE. I just can't recall them all. Anyway, if you are new to this channel, please do make sure that you subscribe and hit the bell for notifications. This is a weekly podcast / video, depending upon where you're watching this. Do not go anywhere. Stay with us. So, you have a passion for epilepsy and neurophysiology, is that correct?
Yes, absolutely.
And you are from the Danish Epilepsy Centre and at AARHUS University Hospital. Did I pronounce that correctly?
Correct. Yes, absolutely.
Oh, I'm on a roll. Okay, cool. So I would like to quote something from Sándor's blog, which will be coming out soon as well. And that was, I think the brain and everything it does are fascinating. And that's what brought you into your profession. I guess that's the basic, but tell us more.
Why neurology, first of all? Well, already in the medical school, as I told you earlier, I found that brain is really fascinating. So if you start thinking of how this works, then you simply get addicted to it. So you want to know more and you want to know more. And then neurology is probably at least in my opinion, is the most logical medical specialty. So it's almost like mathematics. So you really can follow some logical rules. So I love neurology right from the start when I was a medical student, and then I completed the neurology training. Then why epilepsy, you would ask? Well, after I completed my training in neurology, I did a fellowship in clinical neurophysiology. So I learned how to use signals from the nerves, the muscles, and the brain to set the diagnosis. And of course, I learned to read EEG. And basically, EEG brought me to the field of epilepsy.
For everyone who's not quite sure of what neurophysiology is, could you explain it to them, please?
Well, clinical neurophysiology is a subspecialty of neurology. It's a diagnostic field. So we record all kinds of biosignals. For epilepsy, the most important biosignal is the electroencephalography, the EEG. And most patients with epilepsy would know this because you have probably had this examination with many electrodes on the skull. So we record these signals, which are electric signals, either from the brain, as with the EEG, but we can also record from the muscles, like electromyography, or we can stimulate nerves, or we can visually stimulate the patients and record so-called evoked potentials and event-related potentials. So these biosignals are very useful to diagnose various conditions, various diseases in the nervous system, both the central and the peripheral, and also muscle diseases.
Sándor did a presentation the other day online. Which organization was that? ILAE that you did that with?
You refer to the latest seminar or webinar that I gave, and that was organized by the Young Epilepsy section of the International League Against Epilepsy.
So we got about 5 minutes in and I was like, wow, this is amazing. And then everything else either went over my head or went through my missing brain tissue because it was so complex. And people generally think it's just about putting electrodes on your head and that's it. But there's so much more to it, right?
Yeah, so the signals that we record are really informative. So they can help us diagnose epilepsy, and then they can help us in classify and subclassify epilepsy, so that we can choose later on the most appropriate treatment. Having said that, I also want to emphasize that EEG is useful in skilled hands, but it can also be misused because many patients are misdiagnosed with epilepsy. So in tertiary referral centers, we experience that roughly 1/3 of the patients referred to these specialized centers on suspicion of drug-resistant epilepsy turn out not to have epilepsy at all. And then when we look at what caused this misdiagnosis, often an over-interpretation, over-reading of the EEG leads to misdiagnosing epilepsy. So EEG is good, but it also can be abused if it's interpreted by people who did not get a proper training.
So you say 1/3 of people, and so that's, I guess, people who might, for instance, be having non-epileptic seizures. Is that
Exactly.
right? Which is a
right.
Yeah, psychiatric condition rather than
Right. Yeah, that's probably the most common differential diagnostic condition. But we also have seen people with convulsive syncope, with cardiological problem, having these paroxysmal episodes that resembled epilepsy, and then with EEG misread as containing epilepsy kind of signals. And then they turned out not to have epilepsy at all, but have a cardiology condition.
And we sure don't want to be on anti-epileptic drugs when we don't need them, right?
Absolutely.
So, okay, really interesting. So tell us, more about your work and what you do day to day, or how you split your week up, because you're not just an EEG chap, but you do other stuff too, right?
Yeah, so I have 2 affiliations, and there's a logistic challenge in it, because the 2 affiliations are something like 300 kilometers apart from each other.
Wow.
So usually on Mondays I'm in Copenhagen at the multidisciplinary epilepsy team meetings. Then on Tuesday I'm in Dianalund, where the Danish National Epilepsy Center is. Then Wednesday, Thursday I'm at the AARHUS University Hospital, and on Friday I'm back to the Epilepsy Center.
That's like you need your own private jet. It must be exhausting.
Well, a private jet would not be very efficient, because the distance is not so big. So I would have to stow my laptop half of the time of the flight. No, I take a train, and trains are quite comfortable in Denmark. I can book a ticket in the so-called silent zone. And then I have an electric socket, so I can charge my laptop. I have high-speed internet, so it's more efficient than in my office, because I really can work without interruption. And then in my office, that's not really an option.
So how much time do you spend on paperwork versus with patients directly?
On administrative, well, I would estimate that roughly something like 25% of my work would be administrative. So you would call it paper, but nowadays everything is digital. But yeah, administrative work would be something like maybe 25% of my time.
So your patients, how do they vary? Like, it vary in terms of severity of epilepsy or non-epileptic seizures, and intellect or intellectual disability. How does it vary?
Yeah, well, again, first of all, it varies between my 2 affiliations. So at the National Center, we only see elective patients. We don't have acute patients, but we have the most difficult ones. So both diagnostically and therapeutically, the most challenging cases. Now at the University Hospital, we of course have also an acute service. So patients with acute severe brain lesions also come to us for diagnosis. So the two places, at least from my point of view, the 2 places complement each other, because the most difficult chronic patients I see at the Danish Epilepsy Center, and then the acute cases are at the University Hospital.
And given your position, I guess you manage a team or several teams.
Oh yes, teamwork is essential. So there's all the achievement is a team achievement. Yeah.
Do you lecture at universities as well?
Yes, and I teach mainly postgraduate students, rarely graduate students. But yes, in AARHUS we also have much teaching activity.
Gosh, I wish I could be there now and listening to you. It'd be so exciting. I warn you, I'll probably come over at some point.
You're more than welcome.
Thank you. I shouldn't invite myself, should I? Anyway, so can you tell us about some studies that you're currently involved in, some research, and why that's valuable?
Our research topics are mainly around EEG and its application, and also around automated seizure detection using wearable devices. So currently, concerning source imaging, the most important study is a multi-center prospective study that we are coordinating. And this is done under the auspices of EpiCare, which is the European Reference Network for Epilepsy. There are 16 active centers, and so far we have recruited more than 250 patients. So I can say that this is the largest and most robust prospective study done on source imaging. Now, what's source imaging? So as you know, for epilepsy surgery, for the patients who have a focal epilepsy and do not respond to the therapy, and roughly that's 1/3 of the patients, an option is a surgical resection of the epileptic focus. But then the art is really finding where the focus is. And then EEG is one of the important modalities that goes into this pre-surgical evaluation. But as you know, EEG is a two-dimensional thing. There are just some traces on the screen. They were on the paper, but not any longer. So some two-dimensional traces, it's an oscilloscope. So how do you get from there to the actual source in the brain? Well, you do some post-processing, some data analysis, and thereby you can estimate in 3 dimensions in the brain of the patient where this focus is. And this is called the EEG source imaging. You can use also magnetoencephalography signals, then it's MEG, magnetoencephalography source imaging. Now, this study, what we are doing is the largest prospective study for source imaging. So I'm really enthusiastic about the study, and I hope that the results will be good. So in smaller studies, also prospective but smaller scale studies, single center studies, we obtained really good results. So I hope that the prospective multi-center large study will provide compelling evidence for this.
Because you have this involvement with EpiCare, which I'm involved with too, and that's more about the rare epilepsies. So you must work with a lot of people with the rare epilepsies compared to, say, a stereotypical neurologist, if you like.
Right. Yes, indeed. So EpiCare is about rare epilepsy, but it's also about complex epilepsy. So, for example, epilepsy surgery, that's considered a complex case within epileptology. So epilepsy surgery is also within the EpiCare, the European Reference Network, although it's not such a rare thing to undergo an epilepsy surgery nowadays. Although I think it should be considered more often, because we still, sadly, but we can see that patients are referred to such pre-surgical evaluations after having epilepsy for 20 years, which is too late.
Exactly what happened to me. Exactly 22 years before I was considered. And I just, in retrospect, that is absolutely crazy, because you think about all that time you've been on drugs, sometimes unnecessarily, and you may have had injuries that you wouldn't have had you had the surgery earlier, and it so affects your cognitive function a lot. Yeah, so many things. But that's why we want to get people more aware, I think, of all the different surgeries that you can have, but also be aware that your neurologist, your neurophysiologist would not recommend you having surgery if the benefits did not outweigh the negatives.
What we do, and I guess that's the case in all centers, we always inform the patient about the risk and benefit ratio, and ultimately it's the patient and the physician together who make a decision. So it's always up to the patient to decide whether to accept the risk for the benefit that we can estimate that they would have by the surgery. But yeah, the 20 years, that's the average in many countries and many centers, and that's too long. So 2 years is enough to conclude that a patient has a drug-resistant focal epilepsy. So it's basically then on the average 18 wasted years.
But I guess those of us who've been through that can now kind of stand up for those currently younger and say, do you know what? Okay, this is what we went through, and it would be great if this person could get quicker treatment and recognition that these anti-epileptic drugs are not working. What are your other options? Because not everyone can have surgery, right? Not
exactly,
everyone.
Exactly.
So what do you see happening over the next 1 to 5 years, or even 10 years, in terms of your work, the research you're involved with, surgeries? What's going to happen, do you think?
There are two things that will kind of be game changer in this field. And the first is the algorithm and the artificial intelligence, which will help us more and more in analyzing the data, so that we will be able to analyze a larger data set, for example, extend the couple of days inpatient video EEG monitoring, extend to longer home video EEG monitoring. That generates a huge data set, and given the current resources, I mean, there are not so many physicians, skilled physicians available, so that limits also the amount of data that we can assess. But using artificial intelligence, we can speed this up. And then I think that within the next 5 years, we will see so-called hybrid systems in which the algorithms will scan a huge data set, and then we will validate the conclusions of the algorithm, or we will double check the algorithms. So I think that will be a game changer, because we will be able to extend the applications of the neurophysiological investigations. And then the other game changer, I think, will be the wearable devices, especially for seizure detection, but also for seizure characterization and measurement of seizure severity. So I expect that these two things will be game changer in our field within the next 5 to 10 years.
Hence, you wrote a piece of paper on it for ILAE, didn't you?
Right. So we just submitted the guideline. It's a joint guideline, actually, of the International League Against Epilepsy and the International Federation of Clinical Neurophysiology. So we've just submitted a guideline proposal for using wearable devices for automated seizure detection. And the short version of it is that currently there are devices that reliably can detect the generalized tonic-clonic seizures, and probably that's the most important type of seizure to be detected. That's the most dangerous seizure type. But there is good progress with the other seizure types too, but we are not there yet. So concerning the generalized tonic-clonic seizures, yes, we already have validated wearable devices, and then we also highlighted where more research and development is needed for the other seizure types and application.
I'm really glad you said that. You mentioned the other seizure types, because I speak to so many people who don't have tonic-clonic seizures, but it affects their lives just as negatively, or sometimes even more so. At least I say sometimes, at least if one is having a tonic-clonic, at least when it's happening, you are unconscious. I mean, it's awful before and after, but if you're having types of focal, it can just be awful, and there's still, of course, that injury risk. But yeah, no, that's fantastic. Okay, now some real cheesy questions. So what drives you with your work? Why do you keep doing it? And, you know, because you've been doing it a while and things are changing at a rapid pace. What keeps you going?
I think that's exactly what it attracts me, this rapid pace. And, you know, research and development are creative processes. So that's really attractive. So I can't wait coming to my workplace and seeing the new results and trying to figure out how we can proceed. So this creative process, along with the obvious need for these gadgets and devices and algorithms, is really fascinating, and that's what's driving me.
Sometimes I worry about the devices, because as wonderful as some of them are now, and they're getting better and better, sometimes people say, do you know what, this watch that I wear is going to detect every single seizure or brain abnormality, and they rely upon it, and that's not always the best thing to do. Would you agree?
Well, the application must be fine-tuned, so it's very important to achieve as high sensitivity as possible. And then there is also the issue of the false alarms, which still is troubling. Fortunately, the devices that are validated on the market, they have very few false alarms during the night. And then during the day, we can use the active intervention from the patient, just infirming or confirming that this has been a seizure. But yeah, details are really important, both concerning the accuracy of the detection, but also later on how this information is then put into the clinical reasoning.
It must be cool that you can see things from, well, you've got the paperwork, you've got like, you're in a position of, you know, power, I guess. That might not be a nice word, but also you see patients. So you can see things from beginning to end, as well as being involved in the neuroscience, in the mathematics, in all of that. That's pretty cool, right?
Well, yes, I would say we physicians often do not feel as being in power. Often we feel our limitations, and then we wish we could do more, and we don't have power enough to help all the patients. So and that can be frustrating.
Yeah, I was actually going to ask what was the most frustrating thing, because you want to help everyone, but you just can't yet. You never know. That's why we need research into epilepsy. That's why I'm involved with Epilepsy Research UK, because we need funding for this. Even if, you know, we are in recessions now, we still need funding for that to better improve people's lives, right?
Absolutely. And I must say that concerning the funding, well, epilepsy never has been, or at least during my lifetime, never has been one of the top funded areas within neurology. So dementia and stroke and multiple sclerosis always gets the big funding. So indeed, epilepsy is not in a very good position concerning the funding. So we need to do more also to attract attention that this is a serious condition, and then this also needs research and development.
Well, do you know what, coincidentally, just last night I put a page on the Epilepsy Sparks website of some epilepsy charities and foundations. So if people have a few extra pennies, because I don't ever want to put pressure on individuals' patients, because we're all having a hard time right now, but if they want to give to a specific organisation or charity that does especially what they want, because they will do different things. Some are into research, some are more into care. Wow. Then I just put it on there, so because lots of people don't know where to access these things. So how can people check out your work if they want to find out more about you and all the exciting stuff you're doing?
Well, basically my Facebook page is open to the public, so I put quite often research that I find interesting, and of course also our own research. I always post it on the Facebook, and I can also be contacted via that page.
That's fantastic. And I was just thinking also, if anybody happens to read those pieces, those papers, and you're like, oh my goodness, what does that mean? Tell me. And I'll put it on the epilepsy glossary to translate it into layman's terms.
That's a very good idea. Yes, I will definitely do that. Thank you. That's a very good suggestion. Thank you.
Because it's really useful for us lot, because we don't generally speak the lingo. So yeah, thank you. Okay, brilliant. Thank you for speaking with me. It's absolutely fabulous. And like, seriously, like, share it with mums, dads, friends, family and stuff, because this is about making it actually quite interesting and cool to talk about, rather than scary all the time. I don't think, you know, I'm really lucky I got into the position where I started learning really exciting things about epilepsy, rather than just focusing on the negative, of which there's a lot, of course. So thank you for giving us hope, Sándor. That's brilliant.
Thank you. Pleasure on my side.
Today, I thank Sándor Beniczky for sharing his passion for helping people through his amazing work, saving and bettering lives for individuals and families, and positively influencing other clinicians, researchers, and people like you and I from around the world. Sándor has released some really interesting papers actually this year, including ones on, are you ready? Quantitative EEG biomarkers for predicting pharmacological treatment outcomes in major depressive disorder. And given that psychiatric conditions are so common in people with epilepsy, this is really important. Another on how many spikes you need to spot in an EEG for diagnosis. And one on measuring interictal spiking patterns related to epileptic seizures. I will provide the links to those below the recording. Next week, I shall be talking to Simon Keller, Professor of Neuroimaging and Neuroscience in the Institute of Systems, Molecular and Integrative Biology and Director of the Brain Research Using Advanced Imaging in Neurology, or BRAIN Lab, at the University of Liverpool. Follow me on Twitter, LinkedIn or Facebook, and we'd love to hear from you if you have any thoughts about today's show. Do subscribe to our podcast and know that we are always trying to improve what we are doing here for the programme. I'm Tori Robinson. Thanks for listening.